All right, guys, this is the worksheet that you've picked up. If you want help solving the first one, that's what I'm going to do, and then you're responsible for the rest. So number one on solving these, it just wants me to plot the points. So what I'm going to do is I'm going to come in here, I'm going to go to 0, I'm going to go up to 10, which you know is going to be between those two numbers. Then the next one is 2 and 20. And then for 30, 6, 60, 8 is 95, so we're going to go to 90 and then just in between there. 10, 135. 12, 155. So here's that. And then 14, 180. 16, and it is 220. So if you're using the scatter plot and you're looking at it and you notice, okay, I kind of have a linear, but then it kind of starts increasing. We would almost call this a what type of equation? Well, we're going to say it's an exponential. It's not quite linear because it's starting out slow and then it goes really, really fast up. So we're going to call it an exponential instead of a linear. So therefore, when we talk about what is the regression equation that models the data, what we want to do is we want to go in and let me look this up for you. You're going to go in and you are going to look at the regression of it. So look at the regression of it. And this is where you go to L1 and L2 in your calculator. Give me a second to just pull this up for you. So when pulling this up, again, we go to Stat and then Edit, and you're going to enter in your L1s and L2s into that list. So Stat, Edit, start entering those points in there. So here we go, Stat, Edit. Remember, L1 is going to be our X's, which is going to be that year since 1992. So we're talking about 0, enter, 2, enter, 4, enter, 6, enter, and so on. 8. And then you just keep going. Make sure you're entering these correctly. Your calculator is going to calculate this no matter what is there. So you want to make sure they're the right numbers and that they line up. And then we go to L2 and you enter in your 10, and then 20, 30, 60, 95. Yeah, almost didn't press the 9, the 5, and then 135, and you keep going until you've entered them all in. Always double check, look back at your list, make sure that it matches. So 220, enter. So we've got all these points right here. If you didn't trust me on that, remember we can turn this scatter plot on, so you can go to second, y equals, and then enter, enter, and then zoom 9. And I think you can see it here too. It kind of starts really, really low, and then it goes all the way up kind of faster. So if it was linear, we would talk more about something like this, but this is going to be more exponential because of it. So we're going to go to Stat. We're going to go to Calc to get our exponential, and we are going to go to number 0. So if you notice, if I scroll down, you can either hit 0, enter, or you can scroll down. We're trying to find 0, and 0 is where it says exponential regression. You're going to hit enter. Go down to calculate, so you can either do that by arrowing down or hitting enter. And then there's my equation. Notice there's no R value on here because I did not turn the correlation coefficient on. It did not ask me to do that. It just asked me to use the scatter plot to identify it. So from there, we get the equation, which is that we are going to round it to 2 decimal places. So we're talking about 14.48 and 1.21. So here's how we write it. We go back over here. We've got y equals, because it's talking about an equation, 14.48 parentheses 1.21 to the x power, because it's an exponential. Okay, so that's how you enter that. Domain and range of the situation. Well, okay, if we're talking about years, we're starting at year 0 and we're going to go up into infinity. It's going to keep going. So that's how we get that domain of it. So my domain of the situation is going to be 0 to infinity because it's going to keep going, okay? Whereas, and we could start with year 0 as well if you wanted to because it is on year 0. And then notice at year 0 we start with 10 wolves. So for my range, we're going to start with 10 up to infinity because the number of wolves is going to keep increasing. All right, so then it says, using your equation, predict how many wolves there will be when the calendar year is 2012. Well, notice this is not in that years. It's starting since 1992. So we're going to do 2012 minus 1992. Okay, and so when we do that, we get, I'm doing some long math here, some stuff that we haven't done in a while. And so 11 minus 9 is 2, so we get 20. So what we're going to do is we're going to go back to our calculator. We're going to plug that equation into y equals that we just wrote. So we're going to plug in 14.48 open parentheses 1.21 close to the x. And then we're going to hit second graph. And we're going to go down to where we see that x is 20. So we're looking for where x is 20. And where x is 20 is going to be our answer. So right there, and it's going to keep going for a minute because I scrolled far down. Hopefully it won't go past 20. All right, so right here where x is 20, my y is 655.35. Obviously, you can't have 0.35 of a wolf, so we're just going to write 600. Oh, sorry about that, guys. Oh. So let me scroll back down here. We're going to write 655 just like that because that's, again, the number we got there. Okay, so when we predicted how many wolves, we, again, subtracted here. You're going to do that for the rest of your problems, front and back. Turn this in before you leave today.